So the first is the continuity of bonding of conductors. When I do continuity of bonding, I'm looking for everything that is metal. Here I've got a metal part. There's a metal part on the plug there. Here's a metal part over here in the switch, etc. There's a metal part up at the light fitting. So everything that is metal must be bonded. They must be tied together somehow. So first of all, when I do my continuity of bonding, just switch my main off. Take my meter, multimeter, Fluke 175, put it onto the ohm scale, because we're testing for bonding. Then I go to a metal part, and another metal part. And that's telling me I'm getting a reading of 2.50 whatever mega ohms, which is incorrect, because my bonding should be 0.2 ohms. Let me go to another metal part, from this one to this one. There I've got my 0.2. So I know that this metal part, even though there's PVC here, and that metal part, they bonded together through the system. Okay? This one is obviously not bonded. So there's a potential of being electrocuted on this metal part, because there's no earth wire connected onto this metal. Then I go from a metal part, once I've checked all the metal parts, and I go to earth bar. That gives me a reading of 0.2, which tells me that all those other metal parts are bonded to earth with a potential of 0 volts. Okay? The reason why this one hasn't been earthed, I put it in there purposefully for the demonstration, so that when you do test, you can find where there's a fault. Like there's no earth on there. You understand that now? Yes. All metal parts must be bonded. You first check all the metal parts, then you check it to earth. The next one is the resistance of the earth conductor. When they talk about a conductor, they're talking about the wire. So now I want to know what the resistance is of this wire. The longer the wire, the bigger the resistance. So, I go to the earth bar, and I go to an earth inside the socket outlet. It should be connected. There it tells me. It gives me a resistance of 0.2 ohms. So I know that the resistance of that earth wire is 0.2 ohms. Okay. Done. The next test is the earth loop impedance test on the main switch. Now the earth loop impedance test, we use an earth loop tester. And because we're doing the earth loop side, you have a look on the meter, it tells you where loop test is and where c.o.c test is. So for this instance, we're doing the loop test, so we set it on 20 ohms on the loop test side. Okay. Take our leads, one onto the earth, they're clearly marked, green is for earth. The black one onto the neutral bar, and then we go onto the top, onto the incoming. Or we can switch the mains on, switch everything else off, and we go onto the live. It gives me a reading of 226 volts. Now I want to test. It gives me a reading of 0.61 ohms. Is it acceptable or is it not acceptable? That's the question. To work out what it should be, my R max, I say RZ or R max is equal to the voltage incoming, which is 230 volts, divided by twice the amperage on my circuit breaker. So this is 60 amps, so it's 220 divided by 120. And then it gives me approximately 1.2 ohms. And this came on to 0.6 something ohms, which is less than 1.98, hence it's acceptable. Okay? Yes. Understand? Okay. So that's our earth loop impedance test complete. Then we do the elevated voltage on neutral. We use our fluke again, put it onto the volts AC scale, and then elevated voltage on neutral, we're checking the incoming neutral against the earth. Incoming neutral to earth. Change my scale to volts. It gives me 0.6 to whatever volts, which is possible because our elevated voltage on neutral should not be more than 25 volts. If it's 25 volts, we phone the supplier of the electricity, we say we've got a fault on neutral. If it goes up to 50 volts, we stop everything. We don't do nothing. We don't do any more tests. We stop right there, and also we phone the authorities. They must come and sort out their problem. Okay. Insulation resistance test. Our famous tester. Insulation resistance test. Because my supply voltage here is 220 volts, I set my insulation resistance tester on twice the incoming supply, which will be, in this instance, 500 volts. Okay. Then, my mains must be off when I do insulation resistance test. All the other circuit breakers on. Even on my subboard, I can switch everything on. I must remove all appliances. Take out all globes. Switch on all switches. Okay. So all my switches are on. All my appliances are disconnected. Now I can do insulation resistance test. First between live and neutral. Now my reading should not be less than 1 mega ohm. It can be infinity, but not less than 1 mega ohm. Now, if I look at the insulation resistance tester, here is 1 mega ohm. It reads backwards. So it's telling me it's less than 1 mega ohm. In other words, there's a potential fault somewhere. Now to find the fault, I must go through every single circuit. I'll start on the one side, switch this one off. Nothing has changed. The meter is still in the same position. Next one. There I see it's come down a bit. Okay? So I know that on this circuit there is potentially a problem. Put this one back on, nothing happens. Go to the next one. Nothing happens. Go to the next one. Aha! There it's come right down to infinity, and that tells me that then on these two circuits that are still down, there's a fault on either one of those circuits. The first circuit I know now is the stove. Okay. The reason being a fault being there is what I've done is inside here you have a little lamp. Now what is happening is that it's picking up the resistance of that lamp inside there. That's why you're getting that fault. Because I wired it incorrectly. There is a load side and a line side. Your power comes in on the line side. The stove is on the load side. So because I twisted it around, I put my line in on my load and I put my load in on my line. That's why we're getting that thing working incorrect. Okay? That's the fault there. So that I know that that's picking up that fault. I put it there for purpose of, so that you can understand. The next one I know is now on my sub-dB. Now, my sub-dB, I've got to find out where the fault is on the sub-dB. So what we can do is, I will leave the test leads here. And do me a favor, push. Switch off the furthest one. On this one. Still a problem. Switch off the next one. Still a problem. Switch off the next one. Aha! There. Now it's come. Switch the first one back on again. Second one back on. Third one. Ah! What is the third one? Lights. Yes. There's a problem with the light circuit there. The light circuit is this one here. Going up to an halogen lamp. I've got no light switch in that circuit. And the halogen light is giving me a resistance. So that's why there's a problem there. Okay. So now we've sorted out. We know what the problem is. That is why we do insulation resistance test. It could also be that maybe the wires are touching somewhere. And it'll give you a resistance. Okay. Next one. The voltage on the main distribution board with no load. Now I want to check no load. Switch the main on. Switch all the other circuit breakers off. Take my multimeter again. Onto the volt scale. Checking for no load. No load means everything is off. So I'm getting a reading now of 222 volts. That is my supply. No load. Then the next one is they want to know what it is with a load on the system. When you want to put a load on the system, you must switch everything on. What I like to do is I just switch all the lights on. And you can also plug in the stove. Switch it on. And just turn maybe one or two of the plates on. I'm just going to put all of them on 6. All of them. I want to see what load this thing has got. So remember I had 222 volts. Now I check again. Now I've got 214 volts. The voltage has dropped because I'm using current now. In other words, my amperage is increased, my voltage drops. So that tells me my load now is 215 or whatever the case may be. Then the next one they ask me is the voltage at available load, the worst condition. Worst condition means I must go to the point which is a distance away from the main dB. If it's a normal house without any outside rooms, I go to the plug that's in the back room and I go and check the voltage there. In this instance, I've got a sub-dB which is an outside room. I will go to that outside room and I'll go to the plug or whatever that's the furthest in that room and I'll go and check there. But for this purpose, I'll just go to the mains. And it gives me again a reading of approximately 214 volts. Okay? Tells me that the whole circuit has got that drop. Okay, with on load. Okay. I'm still waiting for you guys to bring some stuff so we can cook here. Some of you are hungry by the time you come here at lunchtime. You can cook ngambole, you can cook whatever. You can make cakes and whatever. Right. The next one is the operation of the earth leakage unit. Now, to operate the earth leakage unit, there are two methods. The first one is the very simple one. We just press the test button, and it trips the earth leakage. That's a simple one. Push it down and reset it. The next one we use a socket outlet tester or a polarity tester to check the earth leakage. We plug it in, set it to approximately 30 milliamps and just press the test button and there it trips. Okay? That tells me that if I've got a potentially dangerous kettle at home, or a microwave, or whatever, and I plug it in and I switch it on, this circuit I know should trip the earth leakage. Okay. That is testing of the earth leakage. Then testing whether the earth wire is connected on all socket outlets and the polarity of points of consumption. Those two we can actually put into one. Because they're talking about testing whether the earth is connected on all socket outlets. So if you look at this one, for argument's sake, it's telling me all three wires are connected and they're connected correctly. Okay? It's got a little scale on the meter which tells you what could be the potential problem. Now we go to the next one. This one tells me that there's a neutral fault. Only two lights are shining, and if I read the meter, it tells me there is a neutral fault. Maybe the neutral wire is not connected. Okay? The next one, only one light is shining. So I look again on my range, it tells me one light is live and neutral or reversed. It happens a lot in installations. People just connect up and live and neutral is swapped the wrong way around. Okay? And this little meter will tell you that. So you've checked all of that now. The last test is all switching devices make and break the circuits. All switching devices. Let's switch the mains off now. We can take our multimeter and we can put it onto the diode test, or the buzzer, like you call it. And now we can check if every circuit is making and breaking. Makes and breaks. Makes and breaks. Makes and breaks. Makes and breaks. We can go to the sub-dB and we do the same story. Making, breaking. Making, breaking. Breaking and breaking. So now we know all the circuits are switching, making and breaking. And that concludes the test. As simple as that. 1, 2, 3. Thank you. You can cut now. Cut.